In an immense universe, a little globe revolves around a star. It is the third star in a row. Mercury, Venus, Earth, of the planetary family. It is of a solid core covered over most of its surface with liquid. It has a gaseous envelope. Living creatures fill the liquid. Other living creatures fly in the gas, and still others creep and walk upon the ground on the bottom of the gaseous ocean. Man, a being of erect stature, thinks himself the prince of creation. He felt like this long before he, by his own efforts, came to know how to fly on wings of metal around the globe. He felt godlike before he could talk to his fellow man on the other side of the globe. Today, he can see the microcosm in a drop of water and the elements in the stars. He knows the laws governing the living cell and its chromosomes, and the laws governing the macrocosm of the sun, moon, planets, and stars. He assumes that gravitation keeps the planetary system together. Man and beast on their planet, the sea within its borders. For millions and millions of years, he maintains, the planets have rolled along on the same paths, and their moons around them, and man in these eons has arisen from a one-cell infusorium all the long way up the ladder to his status of Homo sapien. Is man's knowledge now nearly complete? Are only a few more steps necessary to conquer the universe? To extract the energy of the atom? Since these pages were written, this has already been done. To cure cancer, to control genetics, to communicate with other planets, and learn if they have living creatures too. Here begins Homo ignoramus. He does not know what life is, or how it became to be, whether it originated from inorganic matter. He does not know whether other planets of this sun or of other suns have life on them, whether the forms of life there are like those around us, ourselves included. He does not know how this solar system came into being, although he has built up a few hypotheses around it. He knows only that the solar system was constructed billions of years ago. He does not know what this mysterious force of gravitation is that holds him and his fellow man on the other side of the planet, with their feet on the ground. Although he regards the phenomenon itself as the law of laws, he does not know what the earth looks like 5 miles under his feet. He does not know how mountains came into existence, or what caused the emergence of the continents, although he builds hypotheses around these. Nor does he know from where oil came. Again, hypotheses. He does not know why, only a short time ago, a thick glacial sheet pressed upon most of Europe and North America, as he believes it did. Nor how palms could grow above the polar circle, nor how it came about that the same fauna fill the inner lakes of the old and the new world. He does not know where the salt in the sea came from. Although man knows that he has lived on this planet for millions of years, he finds a recorded history of only a few thousand years, and even these few thousand years are not sufficiently well known. Why did the Bronze Age precede the Iron Age, even though iron is more widely distributed over the world, and its manufacture is simpler than that of the alloy of copper and tin? But what mechanical means were structures of immense blocks built on high mountains of the Andes? It is a mystery. Why did brass come before iron if iron is so much easier to make and stronger? What caused the legend of the flood to originate in all countries of the world? Is there any adequate meaning to the term antediluvian? From what experiences grew the eschatological pictures of the end of the world? In this work, of which the present book is the first, of these questions will be answered, but only at the cost of giving up certain notions now regarded as sacred laws in science. The millions of years of the present constitution of the solar system and the harmonious revolution of the Earth, with all their implication as regards to the theory of evolution. The celestial harmony. The sun rises in the east and sets in the west. The day consists of 24 hours. The year consists of 365 days, 5 hours, and 49 minutes. The moon circles the earth, changing its phases, crescent, full, decrescent. The terrestrial axis points in the direction of the polar star. After winter comes spring, then summer, then fall. These are common facts. Are they invariable laws? Must it be forever? Was it always so? The Sun has 9 planets. Mercury has no satellites. Venus has no satellites. The Earth has the Moon. Mars has 2 small trabants, mere pieces of rock, and one of them completes its month before Mars ends its day. Jupiter has 11 moons. This was back in the 1940s when he wrote this, pre-space age. And 11 different kinds of months to count. Saturn has, Jupiter has 79 moons. Saturn has 82. That's the last current. Uranus has 5 moons here. That was what was known by science at the time. I'll just leave it at that. Neptune 1, Pluto none. The Sun rotates in an easterly direction. All planets revolve in their orbits in the same direction, counterclockwise if seen from the north, around the Sun. Most of their moons revolve counterclockwise in direct motion, but there are a few that revolve in the opposite direction, in retrograde motion. No orbit is an exact circle. There is no regularity to the eccentrical shapes of the planetary orbits. Each elliptical curve verges in a different direction. It is not known for certain, but it is assumed that Mercury permanently shows the same face to the Sun, as our moon does with respect to the Earth. Information obtained by different methods of observation of Venus is contradictory. It is not known whether Venus rotates so slowly that its day equals its year, or so rapidly that the night side is never sufficiently cooled. Mars rotates in 24 hours, 37 minutes, 22.6 mean period, a period comparable to the terrestrial day. Jupiter, which in volume is 1,300 times larger than the Earth, completes a rotation in the short space of 9 hours and 50 minutes. It's spinning. What causes this variability? Is it not a law that planets should rotate, or have days and nights? Still less that its day and night must return every 24 hours. If Pluto rotates from east to west, it has the Sun rising in the west. Uranus has the Sun rising and setting neither in the east nor the west, so it is not a law that a planet of the solar system must rotate from west to east, and that the Sun must rise in the east. The equator of the Earth is inclined to the plane of its ecliptic at an angle of 23.5 degrees. This causes the change of seasons during the annual revolution of the Sun. The axes of the other planets point in other directions, of seemingly deliberate choice. It is not a general law for all planets that winter must follow fall and summer equals spring. The axis of Uranus is placed almost in the plane of its orbit. For about 20 years, one of its polar regions is the hottest place on the planet. Then night gradually descends, and 20 years later, the other pole enters the tropics for an equal length of time. The moon has no atmosphere. It is not known whether Mercury has any atmosphere. Venus is covered with dense clouds, but not of water vapor. Mars has a transparent atmosphere, but almost without oxygen or water vapor. Its composition is unknown. Jupiter and Saturn have gaseous envelopes. It is not known whether they have solid cores. It is not a general law that a planet have an atmosphere or water. Mars is 0.15 the volume of the Earth. The next planet, Jupiter, is about 8,750 times as large as Mars. There is no regularity of or relation between the size of the planets and their position in the system. On Mars are seen canals and polar caps. On the Moon, craters. The Earth has reflecting oceans. Venus has brilliant clouds. Jupiter has belts and a red spot. Saturn has rings. The celestial harmony is composed of bodies different in size, different in form, different in the velocity of rotation, with differently directed axis of rotation, with different directions of rotation, with differently composed atmospheres, or without atmospheres, with a varying number of moons or without moons, and with satellites revolving in either direction. It appears then to be by chance that the Earth has a moon, that we have day and night, and that their combined length is equal to 24 hours. That we have a sequence of seasons. We have oceans and water, atmosphere and oxygen, and probably also that our planet is placed between Venus at our left and Mars at our right. The origin of the planetary system. All theories of the origin of the planetary system and the motive forces that sustain the motion of its members go back to the gravitational theory and the celestial mechanics of Newton. The sun attracts the planets, and if it were not for a second urge, they would fall into the sun. But each planet is impelled by its momentum to proceed in a direction away from the sun, and as a result, an orbit is formed. Similarly, a satellite or a moon is subject to an urge that drives it away from its primary. But the attraction of the primary bends the path on which the satellite would have proceeded if there had been no primary, if there had been no attraction between the bodies. And out of these urges, the satellite's orbit is traced. The inertia or persistence of motion implanted in planets and satellites was postulated by Newton, but he did not explain how or when the initial pull or push occurred. The theory of the origin of the planetary system, which dominated the entire 19th century, was proposed by Swedenborg, the theologian, and Kant, the philosopher. It was put into scientific terms by Laplace, although not explored by him quantitatively, and in brief is as follows. Hundreds of millions of years ago, the sun was nebulous and very large, and had a form approaching that of a disk. This disk was as wide as the whole orbit of the furthest of the planets. It rotated around its center, owing to the process of compression caused by gravitation. A globular sun shaped itself in the center of the disk. Because of the rotating motion of the whole nebula, a centrifugal force was in action. Parts of matter, more on the periphery, resisted the attracting action directed toward the center and broke up into rings, which balled into globes. These were planets in the process of shaping. In other words, as a result of the shrinkage of the rotating sun, matter broke away and portions of this solar material developed into planets. The plane in which the planets revolve is the equatorial plane of the sun. This theory is now regarded as unsatisfactory. Three objections stand out above others. First, the velocity of the axial rotation of the sun at the time the planetary system was built could not have been sufficient to enable bands of matter to break away. But even if they had broken away, they would not have balled into globes. Second, the Laplace theory does not explain why planets have larger angular velocity of daily rotation and yearly revolution than the sun could have imparted to them. Third, what made some of the satellites revolve retrogradely, or in a direction opposite to that most of the members of the solar system? It appears to be clearly established that whatever structure we assign to a primitive sun, a planetary system cannot come into being merely as the result of the sun's rotation. If a sun rotating alone in space is not able of itself to produce its family of planets and satellites, it becomes necessary to invoke the presence and assistance of some second body. This brings us at once to the tidal theory. The tidal theory, which in its earlier stage was called the planetesimal theory, assumes that a star passed close to the sun. An immense tide of matter arose from the sun in the direction of the passing star and was torn from the body of the sun, but remained in its domain, being the material out of which the planets were built. In the planetesimal theory, the mass that was torn out broke into small parts, which solidified in space. Some were driven out of the solar system, and some fell back into the sun, but the rest moved around it because of its gravitational pull. Sweeping into elongated orbits around the sun, they conglomerated, rounded out their orbits as a result of mutual collisions, and grew to form planets and satellites around the planets. The tidal theory does not allow the matter torn from the sun to disperse first and reunite later. The tide broke into a few portions that rather quickly changed from gaseous fluid and then to the solid state. In support of this theory, it was indicated that such a tide, when broken into a number of drops, would probably build the largest drops out of its middle portion and the small drops from its beginning nearer the sun, and its end most remote from the sun. Actually, Mercury, nearest to the sun, is a small planet. Venus is larger, Earth a little larger. than Venus. Jupiter is 320 times as large as the Earth in mass. Saturn is somewhat smaller than Jupiter. Uranus and Neptune, though large planets, are not as large as Jupiter and Saturn. Pluto is quite small as Mercury. The first difficulty of the tidal hypothesis lies in the very point adduced in its support, the mass of the planets. Between the Earth and Jupiter there revolves a small planet, Mars, a 10th part of the Earth in mass, where, according to the scheme, a planet 10 to 50 times as large as the Earth should be expected. Again, Neptune is larger and not smaller than Uranus. Another difficulty is the allegedly rare chance of an encounter between two stars. One of the authors of the tidal theory gave this estimate of its probability. You remember the load of dust, the Burnham model? Two specks of dust, 4.5 miles apart, the sun and its nearest star. It's amazing when you look at it that way. At a rough estimate, we may suppose that a given star's chance of forming a planetary system is 1 in 5. That would be millions, billions, trillions, quadrillion. See how many sets of zeros? 1, 2, 3, 4, 5, 6 sets of zeros. With 5 quadrillion years. But since the lifespan of a star is much shorter than this figure, only about 1 star in 100,000 can have formed a planetary system in the whole of its life. But we know that's not true now. In the galactic system of 100 million stars, planetary systems form at a rate of about 1 per 5 billion. Our own system, with the age of the order of 2 billion years, is probably the youngest system in the whole galactic system of stars. The nebular and tidal theories alike regard the planets as derivatives of the sun, and the satellites as derivatives of the planets. The problem of the origin of the moon can be regarded as disturbing to the tidal theory. Being smaller than the Earth, the moon completed earlier the process of cooling and shrinking, and the lunar volcanoes had already ceased to be active. It is calculated that the moon possesses a lighter specific weight than the Earth. It is assumed that the moon was produced from the superficial layers of the Earth's body, which are rich in light silicon, whereas the core of the Earth, the main portion of its body, is made of heavy metals, particularly iron. But this assumption postulates the origin of the moon as not simultaneous with the origin of the Earth. The Earth, being formed out of a mass ejected from the sun, had to undergo a process of leveling, which placed the heavy metals in the core and the silicon at the periphery, before the moon parted from the Earth by a new tidal distortion. This would mean 2 consecutive tidal distortions in a system. The chance of even one is held extremely rare. If the passing of one star near another happens among 100 million stars once in 5 billion years, 2 occurrences like this for one and the same star seem quite incredible. Therefore, as no better explanation is available, the satellites are supposed to have been torn from the planets by the sun's attraction on their first perihelion passage. When sweeping along on stretched orbits, the planets came close to the sun. The circling of satellites around the planet also confronts existing cosmological theories with difficulties. Laplace built his theory on the origin of the solar system, on the assumption that all planets and satellites revolve in the same direction. He wrote that the axial rotation of the sun and the orbital revolutions and axial rotations of the 6 planets, the moon, the satellites, and the rings of Saturn, present 43 movements, all in the same direction. One finds by the analysis of the probabilities that there are more than 4,000 billion chances to 1 that this arrangement is not the result of chance. This probability is considered higher than that of the reality of historical events, with regard to which no one would venture a doubt. He deduced that a common and primal cause directed the movements of the planets and satellites. Since the time of Laplace, no members of the solar system have been discovered. Now we know that though the majority of the satellites revolve in the same direction as the planets revolve, and the sun rotates, the moons of Uranus revolve in a plane almost perpendicular to the orbital plane of their planet, and 3 of the 11 moons of Jupiter, 1 of the 9 moons of Saturn, and 1 moon of Neptune revolve retrogradely. These facts contradict the main argument of the Laplace theory. A rotating nebula could not produce satellites revolving in 2 directions. The tidal theory. In the tidal theory, the direction of the planet's movement depend on the star that passed. It passed in a plane of which the planets now revolve, and in a direction which determined their circling from west to east. But why should the satellites of Uranus revolve perpendicularly to that plane and some moons of Jupiter and Saturn in reverse directions? This, the tidal theory fails to explain. Birkeland currents. According to all existing theories, the angular velocity of the revolution of a satellite must be slower than the velocity of rotation of its parent. But the inner satellite of Mars revolves more rapidly than Mars rotates. Some of the difficulties that confront the nebular and tidal theories also confront another theory that has been proposed in recent years. According to it, the Sun is supposed to have been a member of a double star system. A passing star crushed the companion of the Sun, and out of its debris planets were formed. In further development of this hypothesis, it is maintained that the larger planets were built out of the debris, and the smaller ones, the so-called terrestrial planets, were formed from the larger ones by a process of cleavage. The birth of smaller, solid planets out of the larger gaseous ones is conjectured in order to explain the difference in the relation of weight to the volume in the larger and smaller planets. But this theory is unable to explain the difference in the specific weights of the smaller planets and their satellites. By a process of cleavage, the Moon was born of the Earth. But since the specific weight of the Moon is greater than that of the larger planets and smaller than that of the Earth, it would seem to be more in accord with the theory that the Earth was born of the Moon, despite its smallness. This confuses the argument. The origin of the planets and their satellites remains unsolved. The theories not only contradict one another, but each of them bears within itself its own contradictions. If the Sun had been unattended by planets, its origin and evolution would have presented no difficulties. And that is the common sense of Velikovsky. There's not very much that we do know versus a lot that we don't. And he puts it together in a very easy to comprehend way because there's so much more in Worlds in Collision. Definitely recommend, if you haven't watched it or heard it or read it, to do so because it's eye-opening. That'll do it for this show. Thank you for watching. Please subscribe, give it a like, check out my playlist. I'll see you next time. Take care.